Okay, I'm just adding a few examples at a time. So we've established, I hope, that strings are immutable. And what that means is you can't do something like this. Even though it's essentially at its heart an array of characters, you can't do something like change the first character to, I don't know, a small h maybe. And you'll see that Visual Studio, the IDE, lets you know that this is not possible because it knows it's read-only. Even if Visual Studio, the IDE, was not helping you out, when you tried to run it, it wouldn't work. So what you notice here is that phrase sub 0, phrase sub anything of the string is on the left-hand side of an assignment statement, which means you're trying to change it. But that doesn't mean you can't use phrase sub whatever in, and here's where I'm doing it, in a read-only way. So you're only reading it here. You're not actually trying to change it. So you can do that. So let me tell you, and also introducing this thing, a static member of the string class, a string method called format. We haven't really seen this yet. I'm kind of surprised because usually when I teach C#, it's not forms from the very beginning. It's console applications first, and you have more opportunity to do this string format stuff. For example, write line will do it without even using this method. You have these placeholders. I forget the technical term for this, but this is kind of like if you're used to Java, %D, %S, %C, whatever, what have you, or if you're used to C, same thing, %D, all that kind of thing. These are placeholders, and what it's saying is the placeholder at index 0 matches the first thing after the comma here, after the string that you're printing out, and the placeholder at position 1, the second one, in other words, is the second thing. So what I'm doing here is I'm adding this phrase, phrase sub, and it's going to put in here 0, 1, 2, 3. I'm doing the wrong one, but 0, 1, 2, 3 as it goes through the loop, right? Then it's also going to print out the element that's there, the character that's in that string. So let me just show you. I haven't started really using the text box yet, but when I hit submit, you'll see what's happening. So it's saying the first letter and the first character in the string of characters. So that's what it is. It's an array of characters, essentially, right? It's the big H and so on. So this gives you an idea of how you can think of a string as an array of characters. Though technically speaking, it's only really an array of characters at its heart. It's still an object that has a lot of other things in it. So I'm going to pause there and show you some more things, string methods. Okay, so this is showing you a similar task using for each instead of for. So again, phrases like a collection. It's a data structure. You can iterate over all the members of it. So in this case, I'm doing the same thing, except I don't have the indices and I don't have that pretty phrase, phrase sub I, phrase sub 0, 1, 2. You can make that happen with this too, but it would clutter up the syntax a little bit. I just wanted to show the bare bones example of how for each works. So I'll do another example after the pause. This is a really simple example. It shows you how index of works. So in the common phrase hello world, you need to find a different phrase. This is showing you that the space is at position 5. So what this will do is it'll take this string, has a method called index of, and I'm asking it what the index of is of this string, one character string with a space. This is overloaded, so you could use other data types. So if you wanted to just get the space character alone, that would also work. This is examples in your book, so don't really need to go over it too much, but so that's after, of course, it's after the fifth thing, right? So 0 through 4, that's 5 letters, and hello plus the sixth thing is at 5. So it's telling you the index where that's at. There's a few others with indices. I'm not going to show them all. There's last index, first index, that sort of thing. Last index, because sometimes you'll have more than one space, right? You want to know what the last one is, not the first one or whatever. Let's see. Let's pause and do some other ones. Okay, this one's going to demonstrate starts with. So let me just go ahead and show it. So I'm adding the result of taking the phrase from the text box and seeing if it starts with HEL, because maybe we're tired of hello and all that kind of stuff, right? So let's run this. So if I type hello world, let's just start with the basics. That's true. It starts with HEL, right? Hell no, same thing. Let's do heck no. All right, how about hello? False. Why? Because capital H is not the same as lowercase h. So we'll put a fix in there if we want to bother with that, but I'll show that in a second. Okay, what else? Happy. It's just going to like keep going. So anything that starts with HEL is going to be true. Anything that doesn't, it's going to be false. You can't read it now because we've scrolled off. But that's false again because capital H. So let me tweak this a little bit. I'll do it after a pause, and then I'll show you how you might want to, if you want to ignore the capitalization, I'll show you how to do that. Okay, here we are with the changes made. So if you notice, it's been an hour that I've been doing this, or more. Anyway, I've been doing other things in between though. So one trick, it's really kind of a trick to use to ignore case, is just to make sure what you're comparing it to is all lowercase, and then just make the thing all lowercase. So what this will do, phrase dot to lower, whatever you type in the text box will go into this string. And then what does this do? Let's talk about this a second. Phrase dot to lower, what does it do? It goes to where phrase is in memory, that object, finds what's written there, and then it will squish all the letters down to lowercase, and then return a reference to a new string object that has all lowercase versions of the original object that had maybe mixed case. Again, strings are immutable. So most of the time when you do these things that actually change the string, change in quotes, so phrase dot to lower, what does that do? It just actually doesn't do anything to phrase. It doesn't do anything to the object that phrase is pointing to. What it does is it takes the object that phrase is pointing to, takes all the letters in it, makes them all lowercase, and creates a new string object that has all lowercase, and then it returns a reference to that object. So when you add phrase dot to lower, you're not adding anything to do with phrase. You're adding a new object, a new string object. It doesn't really have a name in quotes. It doesn't have a variable pointing to it. It's just the variable that's pointing to it is the index of the items collection here in the list box. This list box points to a quote anonymous string that has all lowercase letters of this string. If you consider an object having not being anonymous because it's referenced by a variable with a name, then this original phrase, which technically comes from this original string, right? So what happens here is this is pointing, when you say txt string.text, that's creating a string object in memory with a certain address. You're giving that address where this thing's located, this text property is located, to this variable. So they both point to the same thing. And again, when you do phrase.toLower, it takes this object, which is also this object, squishes the letters, and creates a new string object that has all lowercase letters. And that's what you add to the list. Phrase itself is not added to the list in any way. It's just a beginning point for how this object right here was created. Then that object's letters are compared with in this string with this yet again another object. It's just a string with HEL lowercase letters in it. It compares the letters, and if the first three are the same as what's in this unnamed object that we created with toLower, then it returns true. So just to show how that works. So hello world, we expect that to return true because it's HEL lowercase letters, but what about hello world? Also returns true because it's comparing to the lowercase version that we created with toLower. Hel is a goddess, not a goddess, but a goddess in Norse mythology. That's true because HEL squished down to the lowercase. Now you can do the same thing here with uppercase. You could have done the same task really by doing phrase.toUpper, starts with all caps HEL, would have the same basic effect. It's just two different ways to approach it. Heck no still doesn't. It should be still false though. So I hope you get the idea there. So that's introducing two upper, two lower. And it's also reviewing the whole thing about strings being immutable. Again, this two lower is not changing phrase at all. It's creating a new string that's all lowercase version of phrase. Let me pause that. It's 10 minutes. Jeez. Okay, I think this is the last example. And there's a bunch more. You want to make sure you know, be familiar with all of the methods and properties on 269. Be familiar kind of with what they do. Be able to recognize that they exist. There's substring. Split's very important. I'll show an example here in a minute with split, but not in this video. Be sure you can recognize them, because on the I'll just tell you, on the test there'll be a question where it has 3 of these, and then it has an imposter that's not really a string method. So you should be able to pick out the thing that doesn't belong. Make sure you can do that. So you don't even necessarily have to have 100% solid instructions in your head for how each one of these works, but you need to recognize what are valid string methods. This is the benefit of listening to the videos too, because I'm not going to like harp on this and anywhere else. Be reduplication of effort. All right, so so this is how replace works. It's kind of an important one. Sometimes the replace method. Again, let me explain what's going on here. It will take a phrase, and if HEL is in it, it will replace that HEL with HEN, and then it will return a new string object with the changes. So again, immutable, but it's immutable. That doesn't mean you can't create a copy that has some changes in it. That's a whole new string object, which is itself immutable, but that gets, it's immutable all the way down. So let me run this and show how it works. So if you type the phrase we've been teaching as an example, let me do it this way, friend. You can see it replaces the HEL with HEN, and obviously I didn't do the 2 upper or 2 lower thing. So hello, if I do hello friend, it doesn't change that one, because it doesn't have a match on capital HEL, only lowercase HEL. So that's how replace works. It can replace anywhere, not necessarily at the beginning. So, well, let me just show. So, oh hell no. Oh, henlo. Hen'll no. Whatever. You get the idea. It replaces where it occurs. Did I spell that right? Oh, hell. Oh, 2H. No. Oh, it's only HEL, right? So that second L will still be there. I think you get the idea. So that's how replace works. I think that's enough. So yeah, that's enough examples for now. Just don't forget the table. Figure. Is that figure or table? Figure 9.5 on page 269. It's not a table. Anyway, yeah, review that, and I'll bring back with a more comprehensive sort of toy program that shows you how all this stuff kind of goes together.